There's another map showing how the zones are laid out. So when the designer tells you they have to make a map, they have to make a map for us. And that's why they're going to make a map. That's why y'all are going to have to pay for that. Additional requirements. A new requirement that will begin in 2010, if you're not familiar with our requirements. I'm not sure how familiar y'all are. I'll just treat it like they're all new to them. Micro irrigation water quality test will be required. You'll be required to take a water test of your well water that you're going to put in your drip system. You'll be required to give us the results of that water test when you turn in your documentation to get payment on an EQIP contract. We're not going to reject any systems because of the quality of the water. We believe the water is pretty good up there, but we have put together a fact sheet that shows some things that y'all need to look for in that water quality test. They don't cost very much. I think Nick A&M does a water quality test for what? $25. So they're relatively inexpensive, and they will show you if you have low, high, or moderate levels of manganese, some of the constituents that we do find that are a water quality problem. When you take that water quality test, you can mix all the wells together. I would say that if you have something that shows a moderate or high value, you'd probably want to test each well individually. Because, wells on one farm can vary quite a bit from another well on the same farm. Just depends. So a water quality test is required. Those results are, you will be required to give us a copy of the test results to get paid for that system. We require a minimum of 3 gallons per minute per acre. It's always been an NRCS requirement for cautionary irrigation systems. It's in our engineering manual, part of our regulation. For drip systems, we do have a lot of drip systems, micro irrigation systems that are designed on 3 gallons per minute on cotton. I'd say that if you're a corn grower, you need to look at higher levels than that. It's 3 gallons per minute per acre will only allow you to put out about 0.14 inches of water every day. And I don't think that's enough for corn. I think you need to be looking at probably a system around 6 gallons per minute per acre if corn is the primary crop that you're looking at. That will require some difference in the type of emitters that you use with the tank, and it can have some other design effects, but the designers will work through that with you. Those high flow, that's a lot higher flow, it's almost double what some of the systems are. And so if you're putting that on every row, that would relieve some of the problems on the system design. And we do have a pretty high cost share rate for every row systems. I think, they talk about most of the time termination isn't a problem. I think since we've been cost sharing the system since 2002, we've had 2 years where we have had problems terminating cotton. 1 year was a real bad year. We had problems all over the place with drip systems, and 1 year was a moderate year where we had some problems terminating cotton. I don't have much experience with corn, but I'm pretty sure corn's going to be planted earlier than cotton, and that means that it's earlier in the year, and there might be less opportunity for those spring rains. So that might be something that you want to think about if you're thinking about alternate row take in corn. Myself, if I was going to raise corn, I think I'd probably have that take on every row to ensure that I can get returns. But I don't own any farmland either. We do have a minimum requirement of 2-zone operation for our systems. We require 2 zones so that we can do flushing. Most of the microsystems that we cost share are running off of electric wells, and they're running off the maximum flow that's available to that field, and so you can't change the flow rate. So if you need to flush your system, you have to increase your flow somewhere to that zone. The only way you can do that is by having at least 2 zones operating at one time, turning that zone off, and then flushing the other zone. And like Russ alluded to, 3 zones or 4 zones are better. 3-zone system, which means that it operates with 3 zones at one time running, gives you a flexibility that throughout the life of that drip system, you could lose your water by 2/3 and still be able to operate that system. You'd still be able to operate 1 zone at a time. And that would certainly give that system a long life. The system must include a flow meter and a chemigation valve. We require flow meters on all our drip systems. Chemigation and safety valves are required on all the systems because system maintenance uses chemicals. Air and vacuum relief valves must be installed on both sides of the control valves, zone control valves. The system must be designed for the manufacturer's minimum recommended flushing velocity, which is 1.5 feet per second. I include this in here because that will increase the size possibly of the flush manifolds and the supply manifolds, because the NRCS minimum has been 1 foot, but the new standard says 1.5 feet per second in concurrence with the manufacturers, and that could increase the supply manifold size, which may increase the prices of it. When flushing, the maximum flow velocity in pipelines downstream of the control valve is 7 feet per second. And that just means that when you're flushing, instead of the old NRCS standard that we say that you can never exceed 5 feet per second in a pipeline, during flushing will allow you to exceed that up to 7 feet per second just while you're flushing. Each flush valve must have an approved pressure gauge and or Schrader valve. Those are so you can check the system pressure.